You left me on a cliff last time, and you knew you were doing it. All night you'd been reeling me in, convincing me there's really only one motion in the whole world, the rock of a single oscillator, the same little engine hiding inside a pendulum and a plucked string and a trembling atom. And then, right at the door, you turned around and said, but nature almost never hands you just one. Tie a whole crowd of them together, let them talk to each other, and something new walks in. You called it the choir. You said its name was coupled oscillators. And then you shut the door in my face and told me to come back tonight.
I did. And here you are. So let's have your mood up front. You always come in with one.
My mood is that I don't buy it. I think you're overselling. Because I already know what a spring does. You spent a whole evening drilling it into me. So take 2 springs, tie them together, and what have I got? 2 springs. Each one rocking at its own natural beat, minding its own business, and the knot between them is just a knot. 2 soloists in one room. Where's the choir in that? It's 2 solos playing at once.
That's the honest guess, and it's the one nearly everyone makes walking in. So let me stake the whole evening on a single little experiment, and let you call it before I run it. Connect 2 oscillators, start only one of them moving. Leave the other one dead still. Now, what does the dead still one do?
Before you run anything, give me the real scale of what you're claiming. Is this a curiosity, 2 pendulums doing a party trick, or is it load-bearing?
Load-bearing, and it holds up more than you'd guess. What we build tonight out of 2 pendulums is the same machinery under every musical note ever played, under sound moving through anything solid, under the way a warm object hangs onto its warmth. The party trick and the physics of matter are the one idea. So watch the trick closely. It's a small door into a very large room.
Fair enough. That's a big enough claim to keep me watching. So run it. What does the dead still one do? Nothing much, surely. I start the first one swinging. The second one's just hanging there, limp. Maybe it twitches a bit from the tug of the knot. Or, if anything, the knot slowly drags it along until they're both swinging together, side by side, like a pair of dance partners. 2 springs, roughly in step. That's my bet.
Hold that bet tightly, because you're going to lose it in the most interesting way I can arrange. 2 things run this whole night. The first is what happens to your poor, ignored second oscillator. I'm going to call it the sloshing. The second is a set of hidden patterns living underneath the sloshing, the real bones of the business, the normal modes. Chase those 2, and the choir stops being a trick. Let's build the sloshing first, because it's the one that'll rattle you loose.
Fine. Build it. What am I looking at?
2 identical pendulums, hung side by side. Same length, same weight, so each one, left alone, has the very same natural beat. Twins. Now tie a weak little spring between them, a limp, soft thing, joining one to the other partway down. Loose enough that when they both just hang there at rest, it does nothing at all. That soft link is the whole story. Everything new tonight comes pouring out of that one gentle connection.
2 twin pendulums, a floppy spring slung between them. All right. Now?
Now do the thing I described. Pull the first pendulum out to the side. Hold the second one dead still, straight down. And at the same instant, release them both. The first one swinging wide, the second one hanging motionless. And then watch the second one, the one you never touched.
And my bet is it sits there ignored, or gets dragged into swinging along beside the first.
Watch what it does. The first pendulum swings, big healthy arcs, and each time it swings, that little spring gives the second one the faintest tug. One tug does almost nothing, but the tugs keep coming, in time, over and over, and they add up. Slowly, you have to be patient with it, the second pendulum, the one you left for dead, begins to stir. A small sway, then a wider one. It's gathering motion out of nowhere.
Out of nowhere from where, though? I didn't lay a finger on it.
You didn't. It's borrowing. And here's the part that gets people, so keep watching. As the second pendulum swells up, the first one, the one you started yourself, is fading. Its arcs are shrinking. It's going quiet. And it keeps fading as the second keeps growing, until you reach a moment where the first pendulum, the one you launched, hangs nearly dead still, and the second one, the one you never touched, is swinging wide for the both of them. The motion has crossed clean over.
Wait, hang on. The one I started has stopped, and the one I never touched is now doing all the swinging. They've completely swapped.
Swapped, top to bottom. And it doesn't stop there. The second pendulum now plays the part the first one played. It feeds the swing back across that little spring, and the motion comes crawling home again. The first pendulum wakes back up, the second dies away, until you're right back where you started. First one swinging, second one still. And then it does the whole thing over. Back and forth, the swing sloshing from one pendulum into the other and home again, endlessly, and neither one of them ever gets to keep it.
And is that trading steady, like clockwork, or is it ragged, coming and going?
Steady as clockwork, in the frictionless ideal. And notice there are two rhythms nested here, one fast and one slow. The fast one, each pendulum swinging out and back, quick. And riding on top of it, a slow one. The swing swelling and fading in each pendulum as it hands across and comes home. Fast rocking, wrapped in a slow breathing. You catch the quick swing at a glance, the slow slosh you only see if you sit and watch a while.
Does it ever just stop in the middle, both of them sharing the swing evenly, and stay there?
It sweeps through that even sharing instant twice every slosh. Once on the way over, once on the way back. But it never rests there. Nothing holds it. It's like a ball rolling through the bottom of a valley. Dead level right at the middle, but it's moving, so it sails straight through and climbs the far side. The pair passes through equal sharing and keeps right on draining into the other pendulum.
Okay, that is flatly not what I said. I said they'd settle into swinging together, side by side, like partners. This isn't together at all. It's one, then the other, then the first again. They take turns.
They take turns. Your swing along together was the natural picture, and it's wrong in a pointed, useful way. The two never share the motion evenly for long. It's always draining out of one and into the other. That draining, that trading, is the first star I promised you, and notice where it lives. It's not in the first pendulum, which on its own would just swing and slowly die. It's not in the second, which on its own would just hang there forever. It only exists because of the link between them. Snip that little spring, and it vanishes on the spot.
So the sloshing isn't a property of either pendulum, it's a property of the connection.
Of the connection, and of nothing else. That's the first genuinely new thing coupling buys you. A behavior that belongs to neither part alone, only to the pair of them together. Now, before we crack it open, let me hand you back a rule you already own, from the Energy Night 2 episodes ago.
The landscape of energy. Go on, where's it hiding in here?
Not the landscape this time, the bookkeeping under it. 2 nights back, you built the rule that energy is never made or destroyed, only shifted, from one form to another, or from one place to another. The grand total holding dead level, while the pieces trade around underneath. Now look at the sloshing with that eye. When the first pendulum swings wide, nearly all the energy is in it. When it's crossed over, nearly all the energy is in the second. In between, it's shared. But add the two together at any instant you like.
And it's always the same total. The energy isn't appearing or vanishing while they trade, it's just changing address. Out of the first pendulum, into the second, and back again.
Changing address. The sloshing is energy pouring back and forth between two rooms, with that little spring as the doorway between them, and the grand total never so much as flickering. So nothing from that night is broken here. The swing you started with is all the swing there will ever be. It simply refuses to stay in one place.
Now hold on. A real one of these would run down though, wouldn't it? Nothing swings forever. You taught me that yourself.
A real one runs down, yes. Friction slowly bleeds the whole thing towards stillness, the way it bled every swing last time, scattering the motion off into warmth. That's the damping from before, still in the room, but set it aside for tonight. Underneath the slow fade, the trading goes on just the same. The swing sloshes from one pendulum to the other, while the total quietly shrinks. Picture the frictionless ideal, where it never stops trading, and you'll see the mechanism cleanest.
Give me something every day for it though. 2 pendulums and a lab spring isn't a thing in my kitchen.
Then picture 2 children on neighbouring swings, with a slack rope looped loosely between them. One child is swinging hard, the other is just dangling there, feet down. Every pass, the rope gives the dangling one the faintest tug. Now, nobody pumps their legs, nobody does anything else, and slowly the swinging child winds down, while the dangling one, tugged over and over on the beat, climbs. Given time, they'd trade the whole way, the first hanging quiet, the second sailing wide. And it's a slow, patient thing, because the rope's a weak link.
And I'd guess the weaker the link, the slower the trade.
The weaker the link, the slower and grander the trade. A stiff, strong coupling sloshes the swing across quickly. A whisper of a coupling sloshes it slowly and grandly, taking its sweet time. Hold on to that. The weaker the link, the slower the trade.
All right, I'm properly hooked and I want to fight it. You've shown me this restless thing that can't sit still, always draining one way or the other, never settling. So here's my pushback. Is there any way at all to start these 2 pendulums so the sloshing just doesn't happen? So they rock steady and never trade?
There is. And there are just 2 ways to do it. No more, no fewer, for 2 pendulums. Find those 2, and you found the bones underneath the whole restless business. Let me hand you the first, and I think you can call what happens before I say it.
Try me.
Take the 2 pendulums and start them swinging together. Side by side, both pulled out the same way, the same distance, released at the same instant. So they move as a pair, always pointing the same direction, always keeping the same gap between them. Now think about that little spring slung between them. As they swing along together like that, what's happening to the spring?
If they're always keeping the same gap, then the spring never changes length. It's never stretched, never squeezed. It just rides along between them, limp.
So what's it doing to the motion?
Nothing. If it's never stretched, it never pulls. It may as well not be there. So each pendulum just swings like it's alone, at its own plain, natural beat. The one from last time.
There it is, and you called it. When they move together in lockstep, the coupling spring is dead weight, never stretched, never pulling, so the 2 of them rock precisely as they would with no spring at all, at that plain, natural rhythm you already know cold. Together, on and on, no sloshing, nothing trading. That's the first of the 2 special patterns.
That one I'll take credit for, though it feels almost like a cheat. The spring's there, but it's asleep. What's the second one?
The opposite, in the most literal sense there is. Start them swinging dead against each other. Mirror images, one going left just as the other goes right, so they swing toward each other, then apart, toward, apart, opposed the whole way. Now ask the same question. That little spring between them, what's happening to it this time?
Now they're not keeping their gap at all. When they swing toward each other, the gap closes and the spring squeezes. When they swing apart, the gap opens and the spring stretches. So this time the spring is working every single swing. Stretch, squeeze, stretch, squeeze.
Every swing. So now the spring is emphatically not asleep. On top of each pendulum's own pull toward home, the spring throws in a pull of its own. When they fly apart, it hauls them back together. When they crush, it shoves them apart. Either way, it's helping drag each one back toward home on every pass. Now cast your mind back to last time. If you pile an extra restoring pull on top of the one that's already there, what does that do to the beat?
More restoring pull means stiffer, and stiffer meant faster last time. A stronger haul home hurries the thing back. So this opposed pattern rocks faster than a lone pendulum would, higher, quicker.
Faster and higher. The opposed pattern rocks quicker than either pendulum could manage alone, because the spring is throwing in extra restoring force on every swing, stiffening the whole motion. And, just as before, no sloshing. Because they're locked mirror against mirror, neither one drains into the other. They just rock, opposed, on and on, at this new higher beat.
Wait, let me make sure I've got the direction the right way round, because I'd have bet on the opposite. I'd have thought tangling two pendulums up with a spring would gum them up, make them heavier, sluggish, slower. But you're telling me the opposed one comes out faster than a lonely pendulum.
Faster. And it's worth being sure of, because the guess you just named is the common trap. The coupling doesn't drag the motion, it stiffens it. The spring only ever wakes up in the opposed pattern, and when it's awake, it's adding to the pull toward home, never subtracting from it. More pull home means a quicker return, means a higher beat. So of the two patterns, the together one is the plain old beat, the spring fast asleep. The opposed one is quicker, the spring wide awake and pitching in. Slow and together, fast and opposed, never the other way about.
You keep saying two and only two. Why not a third steady pattern? Surely I can invent some other way to start them.
Try it. Go on. Describe me a third one. Some way to start them so they rock steady and never trade.
What if I swing the first one wide and the second one only a little, both going the same direction? That's not the even together pattern, and it's not the opposed one. Isn't that a third?
Start it that way, and it won't rock steady. It'll slosh. That lopsided start isn't a single pattern at all. It's a blend of my two, in unequal helpings, and the two beats will drift and set it trading. The reason there are two and no more comes down to counting. Two pendulums means two independent ways they can move, so two, and only two, pure patterns to build everything else out of. As many pure patterns as there are movers. Hold on to that count.
So these two, the lazy together one and the quick opposed one, these are the special patterns you promised. The ones with no sloshing in them.
These are the ones, and they've earned a name worth carrying out the door. The normal modes. A normal mode is a way of moving where the whole system rocks at a single definite beat, with every part swinging in fixed proportion to every other. Nobody drifting, nobody trading, the entire contraption moving as one object. For two pendulums, there are these two, and only these two. The slow together mode and the quick opposed mode. And each one, once you start it clean, is as simple and steady as a single lone oscillator from last time. It just rocks.
So a mode is the coupled system pretending to be one big single oscillator, rocking at its own one beat.
That's a good way to hold it. In a mode, the whole coupled thing behaves like one clean oscillator with one rhythm. All the tangle gone. Two pendulums, so two of these disguises. Let me anchor it with a picture. Two swings again. In the first mode, both children swing forward together and back together, in unison, a lazy, easy rhythm. In the second, one swings forward at the very moment the other swings back, always mirror opposite, and that one runs plainly quicker. Two clean, unchanging patterns. No trading in either.
Let me poke at fixed proportion, because you slid it in and I want it pinned. What does it mean that the parts stay in fixed proportion?
It means the ratio between how far each part swings never changes as the motion runs. In these two twin pendulums, it's the simplest it can be. In the together mode, both swing the same amount, always, a one-to-one match side by side. In the opposed mode, both swing the same amount again, but always in opposite directions, mirror for mirror. Neither pendulum ever pulls ahead in size. That fixed, frozen relationship between the parts is the signature of a mode. The sloshing had no such thing. There, the sizes were forever shifting, one swelling as the other shrank. A mode holds its shape. The sloshing never does.
Fine, but those two are very tidy, very special ways to start it. I had to set each one up just so, with a careful hand. Almost nothing I do to those pendulums is going to be one of your two neat patterns. So what have they got to do with the messy sloshing I started with, where I just yanked one and dropped the other?
Everything. They are the secret of it. Go back to that messy start. First pendulum swinging, second dead still. Here's the claim. That messy motion is nothing more than your two tidy modes running at the same time, added together.
Added together how? I started one pendulum. I didn't start any modes. I don't even know how you'd start one and not the other.
You started both without meaning to. Follow this. Take the together mode and the opposed mode and imagine running them both at once, each the same size as the other. At the very first instant, line them up so that on the first pendulum they agree. Both patterns saying, this one, swing out, and they pile up into one big swing. But on the second pendulum, at that same first instant, the two patterns disagree. One says, swing this way, the other says, swing that way, and they cancel dead. So the second pendulum doesn't budge.
So at the start, the two modes add up on the first pendulum and cancel out on the second, which is the exact picture I set up by hand. One swinging, one still.
That very picture. Your messy start was never messy. It was these two clean modes, laid one on top of the other, arranged to agree on one pendulum and cancel on the other. That's all it ever was. And now, watch the sloshing fall straight out of it. Remember the two modes' beats. The together mode, slow, the opposed mode, a touch quicker. The two don't quite share a rhythm.
Then I think I see the trouble. If the opposed one runs even a touch quicker, the two can't stay lined up, can they? So what becomes of my neat arrangement, agreeing on one pendulum and cancelling on the other once they start sliding apart?
Just so. They can't stay lined up. They start in step, agreeing on the first pendulum, cancelling on the second. But the opposed mode, running faster, gradually pulls ahead of the together mode. They drift out of step, and as they drift, the spot where they add up and the spot where they cancel slowly slide across from the first pendulum to the second, until they've drifted so far that now they cancel on the first pendulum and add up on the second.
And that's the instant the motion has fully crossed over. The first one's gone still, the second swinging wide. That's the swap. That's the swap I watched happen.
That's the swap. And it was never some mysterious fluid draining through a spring. It was two pure, steady rhythms, each one dead simple, each just rocking at its own beat, sliding slowly in and out of step with one another. When they're in step, the first pendulum has the swing. When they've slid to opposite, the second one has it. The sloshing is the drifting. Two clean beats, beating against each other.
Let me say it back, because this genuinely turns the thing inside out. The sloshing looked like the star of the show, the restless trading, the headline act. And you're telling me it's not even a real thing on its own. Underneath, there are just two dead simple rocks going at once, at slightly different speeds, and the sloshing is only what I see when I don't realize I'm watching two clocks slowly drift past each other.
That's the whole of it. And now you can go back and explain the thing I made you file away. Why does a weaker link make a slower, grander slosh?
Let me try. Weaker link. The spring's barely there. And the spring was the only thing that made the opposed mode faster than the together mode. So a weaker spring means the opposed mode is only barely faster. The two beats are almost the same. And if the two beats are almost the same, they drift apart very slowly. so the slosh takes forever to come around.
You just built it yourself. The whole timing of the trading is set by the gap between the two mode beats. And mind what that means. Both modes rock at nearly the same quick beat, close together. The slow slosh isn't either one of them, it's only the narrow gap between their two beats, breathing slowly open and shut. Weak link, tiny gap, slow lazy drift, a stately slosh. Strong link, big gap, fast drift, a quick slosh. The sloshing that looked like its own separate phenomenon is nothing but a measure of how far apart the two hidden rhythms sit.
And you're claiming this holds for anything I do to them, not just my one messy start.
Anything at all. However you pull, push, twist, or release those two pendulums, any start you can dream up, the motion that follows is some blend of the together mode and the opposed mode, in some mix, lined up some way. Those two are the true building blocks. The system doesn't really know about pendulum 1 and pendulum 2 as separate things. Those just happen to be the handles you can grab. What it's really built out of, underneath, is the two modes.
Give me an everyday feel, for any motion is a blend of the modes. Because said flat like that, it's slippery.
Think of colour. Every shade a painter mixes, every muddy brown, every sunset orange, is some blend of a few base colours in some recipe. You don't have infinitely many separate paints, you have a small set of pure ones, and everything else is those, mixed. The modes are the pure colours of the motion. Every possible way the pair can move is some recipe of the two modes. And the reason they're the right base to mix from is that they don't meddle in each other's business. Start both, and each just rocks along at its own beat as though the other weren't there, neither trading with the other. Independent, simple. Each one a lone oscillator from last time, wearing the whole system as a costume.
So the size of the slosh just tells me how much of the opposed mode I stirred in by accident.
That's the reading. Pure together mode, no slosh at all. A whisper of opposed mode, a faint slosh. Equal helpings of the two, which is what my very first yank one and drop the other start was, and out comes the full slosh, the swing crossing all the way over and back. The amount of trading is a direct measure of the recipe. Read the slosh and you've read the blend.
So the trick for making sense of the coupled mess is stop staring at the pendulums and start watching the modes.
Stop watching the parts, watch the patterns. The parts look like they're doing something hopeless. Draining, swelling, trading, no rest. The patterns are each doing the simplest thing in the world, rocking steadily at one beat. The tangle was an illusion of looking at the wrong thing. Find the modes, and the complicated motion dissolves into a few simple rhythms added up.
All right, two pendulums, two modes. And I can feel you about to make me greedy. What if I've got more than two?
Then you get more modes, and the rule is strict as a ruler. Line up 3 masses on a row of springs, each joined to the next. How many special in-step patterns do you think it has?
If 2 gave 2, I'll guess 3.
3. As many modes as there are moving pieces. 3 masses, 3 modes. 3 ways the whole row can rock at a single shared beat with everyone in fixed proportion. And you can half see them already. In the slowest, all 3 lean and sway roughly together, a gentle rocking, the springs between them barely stretching. In the fastest, each mass throws itself opposite its neighbours, the middle one lunging one way while both its partners lunge the other. So every spring is stretched and squeezed hard, a jagged, buzzing pattern. And one more in between the two.
And each of those 3 on its own would just rock steadily, no sloshing.
Each one on its own rocks steadily at its own single beat. No trading. A normal mode, same as before. And, same as before, any messy way you happen to start the 3 masses is some blend of these 3 modes, running at once and drifting against each other. 2, 3. It's the same story, just with more drawers to sort the motion into.
Paint me that middle one of the three, the in-between mode. The slow and the jagged I can picture, but the middle's fuzzy.
In the middle mode of three masses, the two outer masses swing opposite each other, while the one in the very middle barely moves at all. It sits near still, a pivot, while the ends seesaw about it. A pattern with a quiet heart and two busy ends. Slower than the all-opposite jagged one, quicker than the altogether smooth one. The middle rung of a three-rung ladder.
And which of the three do I get if I just grab one mass and let go?
A blend of all three, running at once and drifting. The same story as the pair, only now with three rhythms sliding against one another instead of two. Grab the row anywhere, start it any way, and the motion that follows is some recipe of the three modes. The modes are the pantry. Whatever you cook is made of them.
Then do it to me for real. Not three, a whole long chain, many masses, many springs, strung out down a line.
A long chain then, many masses, each tied to its neighbours, running off into the distance. And the rule doesn't so much as blink. Only now the modes spread out into a whole ladder, bottom to top. Down on the bottom rung, the slowest, smoothest pattern, where each mass leans almost together with its neighbours so the springs barely stretch, and the whole chain bows up and down together in one long, lazy arc, swelling and sinking in place, never rolling along the line. Climb the ladder and the patterns get faster and choppier, neighbours disagreeing more and more, the springs working harder. At the very top rung, the fastest, most jagged pattern of all, every mass flung opposite its neighbours, every spring stretched hard, the whole chain a shivering zigzag.
Give me one I can watch shiver.
Picture a long, loose clothesline with weights pegged along it at intervals, or a child's coil spring toy stretched across the floor, a row of little masses on springy links. Set it going right, and you can pick out each pattern. The bottom mode, the whole line sways in one slow, smooth arc, everything drifting the same way at once, like a rope lifting in a gentle breeze. The top mode, every weight jitters against its neighbours, up, down along the line, a tight, fast quiver. And between them, a whole staircase of patterns, smoother and slower toward the bottom, choppier and faster toward the top.
And you're telling me the smooth is slow, jagged is fast thing is the same rule as my two pendulums?
The identical rule. Run up and down a ladder. Think about why. In the smooth bottom pattern, neighbours move nearly together, so the springs between them barely stretch. Soft, lazy, slow, exactly the sleepy together mode of the two pendulums. In the jagged top pattern, neighbours fly opposite, so every spring is stretched and squeezed hard on every swing. Stiff and so quick, exactly the wide-awake opposed mode. Smooth means the springs relax, which means slow. Jagged means the springs strain, which means fast. It's the two pendulum lesson, played out over a whole line.
And does anything big and everyday sit in one of these chain patterns, beyond weight strung on a clothesline?
All the time, once your eye is trained for it. A tall building is one, if you squint. Think of it as a stack of floors linked by springy structure. A chain stood up on its end. Give it a shove, a gust or a tremor, and it sways in its patterns, and the slowest, smoothest one takes over. The whole tower leaning one way and easing back as a single long, lazy arc, the bottom rung of its ladder. And the taller you build it, the slower that sway rolls. The lower its deep note, so to speak. A short, stiff tower quivers quick. A tall one sways slow and grand.
So a skyscraper carries a fundamental the way a plucked string does.
In the very same breath of physics. A long bridge, a tall mast, a skyscraper. Each is a chain of coupled pieces with its own ladder of modes, and each has a slowest, grandest sway sitting at the bottom of that ladder. That slow sway is the one a wind can catch and pump, cycle on cycle. The resonance from last time, aimed square at a structure's lowest mode. It's why the people who build tall things care, to the point of obsession, what a structure's slow sway comes out to be. The same ladder as the guitar string, only drawn on the scale of a city skyline.
And the count stays dead exact all the way up? As many patterns as pieces?
Dead exact. Every moving piece you add buys you one more rung on the ladder. One more pattern, no more, no less. That's a promise the underlying mathematics keeps to the letter. Though we're doing the whole thing in pictures tonight. Many pieces, just as many modes. A whole ordered ladder of in-step patterns, and any motion of the chain, a blend drawn from that ladder.
A ladder of patterns on a chain of weights. I'll grant it's elegant, but it's starting to feel abstract. Where does this touch anything I care about?
Here's where it comes home to something you know in your body. Take that chain and make it longer and finer. More masses, smaller, closer and closer together, until it stops looking like beads on springs and starts looking like a single smooth, taut string. A guitar string, a violin string. The chain's normal modes don't disappear when it becomes a string. They turn into the shapes a string can hum in. And those shapes are standing waves.
Standing waves. The shapes I've watched a skipping rope make. One big arc, or two humps, or three.
Just those. The slowest, smoothest mode, the bottom of the ladder, is the string swinging in one graceful arc, the whole length bowing up and down as one. The next mode up, the string splits into two humps, one rising while the other falls, with a still point pinned in the middle. Then 3 humps, then 4, on up the ladder, each pattern faster and more finely divided than the one below it. Those are the string's normal modes, and every one of them is a standing wave.
And I've made the low one with my own arms, twirling a jump rope. The whole thing sweeping round in a single arc. So these aren't exotic at all.
You've been making the bottom of the ladder with your arms your whole life. Now here's where it turns into music. The modes of a string have a second name, one you've heard. The slow single arc mode is the fundamental, the main note you hear when the string sounds. The 2-hump mode rings at a higher pitch, the 3-hump higher still, and those higher ones are the overtones, stacked up above the fundamental. A whole ladder of pitches, from the one deep note up through a stack of higher ones, all sitting inside the one string.
Hold on though. When I pluck a guitar string, I hear one note, just the one, not a ladder, not a stack, one clear pitch. So surely a plucked string is just doing that one bottom mode, and all these overtones are something you'd have to go out of your way to coax out of it.
That's the natural thing to think, and it's the second place tonight your instinct's going to come up short. When you pluck a real string, grab it somewhere, pull it into a corner, let it go, you don't wake up only the fundamental. You wake a whole blend of modes at once. The fundamental, loud, plus a stack of overtones mixed in behind it, each one ringing at its own strength. The string is doing many of its patterns at the same instant, all added together. The same blend of modes idea from the pendulums, now singing out loud.
But then, why on earth do I hear one note and not a jangling chord?
Because your ear takes the fundamental as the note. That's the pitch you'd name, and hears the overtones not as separate notes, but as the color of it. The particular recipe of overtones, which ones are loud, which are faint, is what makes the sound rich instead of thin. And here's the good part. It's what makes one instrument sound unlike another. A violin and a flute playing the very same note, the same fundamental, sound nothing alike. Why? A different recipe of overtones, a different blend of modes riding on top of the same bass note.
So the difference between a flute and a violin isn't the note at all. It's which modes each one mixes in behind it.
That's the whole of it. Same fundamental, different stack of overtones, a different blend of the instrument's normal modes, and your ear names it flute or violin the instant it hears it. Music, right down at the bottom, is normal modes made audible. Which patterns are ringing, and how loud each one sings. That pluck you are sure was one clean note is a little crowd of modes singing together, and the makeup of the crowd is the sound's fingerprint.
Can I test that? If it's really a blend, I ought to be able to change the blend and hear it shift.
You've done it if you've ever played. Pluck a string right up near its end and it sounds bright and biting. Pluck it gently over the middle and it sounds round and mellow. Same string, same note, but plucking near the end wakes a richer stack of overtones, while plucking at the middle leaves them fainter. You're reaching in and stirring the recipe of modes with your fingertip, and your ear hears the recipe change straight away. And for the opposite extreme, strike a tuning fork. It comes about as close as anything to a single pure mode, almost no overtones at all, which is exactly why it sounds so plain and hollow next to the ring of a plucked string. Nearly one mode, colourless. A rich blend of modes, alive.
One thing nags me. Why do the strings' pitches come out as a neat ladder, a clear stack of separate notes, and not a smeared mush of every pitch under the sun?
Because the string is pinned at both ends, tied down, held still where it's anchored. So only the patterns that fit neatly between those two pinned ends are allowed on it. One clean hump spanning the length, or two humps, or three, or four. A pattern that didn't come out even at the pinned ends simply can't sit on the string. Whole humps only, so the pitches land on a tidy ladder, one rung for each number of humps, with clean gaps between them. The pinned ends are what sort the smear into a stack.
So the shape of the boundary, where it's tied down, is what picks out the ladder.
The boundary chooses the modes. Pin a string at both ends and you get that even stack of humps, the tidy musical ladder. Change what's holding the edges, a drum head pinned all around a circle, a bar clamped only at one end, and you get a different set of allowed patterns, a different ladder. Which is why a drum, whose modes don't stack up in that neat, even way, sounds more like a thud with a colour in it than a clear sung note. Same idea, different boundary, a different family of modes.
And I can feel the ghost of last time standing in the doorway here. Resonance. You spent a whole evening on driving a thing at its own beat. Does that come back now, with the modes?
It comes straight back, and it comes back sharper. Last time, a lone oscillator had one natural beat, and driving it right at that beat made it drink in energy and swell. The swing pumped high, the wine glass singing itself to pieces. Now the system hasn't got one natural beat. It's got a whole ladder of them, one for each mode. So resonance turns choosy in a new way. Drive the system at one particular mode's beat, and that one mode drinks the energy and builds, while all the others, off the beat, stay quiet. You can pour energy into a single chosen pattern just by matching its rhythm.
So that wine glass from last time
Is really this all along. The glass isn't a single, simple oscillator. It's a body with its own modes, its own ladder of patterns it can ring in. When a voice sings its pitch, it's matching one of those modes, pouring energy into that one shivering pattern of the glass, over and over, right on the beat, until that one mode swells past what the glass can bear, and it flies apart. The shattering glass was a normal mode, driven to resonance the whole time. Last time, we just hadn't named the pattern.
Can I pick out a single mode on purpose? Not by shattering anything, just coax one overtone to ring on its own.
You can, and string players do it constantly. Rest a fingertip ever so lightly at the midpoint of a plucked string. Just touch, don't press it down, and you hush every pattern that wants to move at that midpoint, while the ones that hold a still point right there sail on untouched. Suddenly the string sings a pure, bell-like high tone in place of its usual rich note. You've reached in and silenced part of the choir, letting a single higher mode ring clear.
So I can add modes in by plucking or subtract them out by touching. Either way, I'm working the recipe.
Working the recipe, both directions. Pluck to wake a blend, touch to hush part of it, drive on a mode's beat to swell one alone. 3 different hands on the same set of patterns. Once you know the motion is built of modes, every one of these tricks is just you reaching in and choosing which of them get to sing.
You've been dangling the physics of solids since last time too. Cash it. Though I'm watching to see whether you really can, or whether it turns to hand-waving.
A fair thing to watch for, and I'll keep it a gesture on purpose. The room past this door is enormous, and tonight we only stand in the doorway of it. Here it is. Take everything you now know about a chain of masses on springs and shrink it all the way down. A solid, a crystal, a bar of metal, a grain of salt is, underneath, a vast orderly chain of atoms, each one held to its neighbours by bonds that behave like little springs. Not a single line of them, a whole three-dimensional web, but the idea is the chain scaled up past all counting.
So a solid is a giant coupled oscillator system, atoms where my masses were, springy bonds where my springs were.
That very thing. And so a solid has normal modes, a vast ladder of in-step patterns its atoms can shiver in, from long, slow, smooth ones to short, fast, jagged ones, just like our chain. And those modes aren't idle bookkeeping. They are how sound travels through the solid. A sound wave running through is one of those patterns, running through. And they are how the solid holds and carries heat. Heat, down at this level, is those countless little atomic patterns all a-shiver. And as the thing warms up, more of those patterns get stirred into motion, and harder. Whether a material rings like a bell or thuds like a stone, whether it carries sound quick or slow, it traces back to its modes.
Does that pin down something as plain as how fast sound moves through a thing? Sounds quicker through steel than through air. I know that much.
It does, and it lands right back on last time's 2 dials. Sound through a solid is those modes running along the chain of atoms, and how quick they run comes down to the same pair we set the beat with before: stiffness and mass. Stiffer bonds hurry the pattern along, heavier atoms drag it slow. So a stiff, light material carries sound fast, a floppy, heavy one carries it slow. The very same 2 dials from last time, now setting the speed of sound instead of the pitch of a swing.
So even the speed of sound is just the mode rhythm wearing another hat.
Another hat on the same head. Stiffness and mass set a lone oscillator's beat. They set a coupled system's mode rhythms, and they set how fast those rhythms march down a chain, which is the speed of sound through the stuff. One little pair of dials turning up everywhere you look, from a swing in a park to sound tearing down a steel rail.
That's a lot of the world resting on the same picture I just learned off 2 pendulums and a floppy spring.
The same picture all the way down. Sound moving through steel, heat creeping up a spoon, the ring of a struck bell, the pitch of a xylophone bar, the note of every instrument there is. All of it is coupled oscillators and their modes, the exact thing we built tonight from 2 twins and a soft little link. A bell rings because it has clean modes to ring in. A lump of clay barely has any, so it only thuds. That's the reach of the idea. And I'll leave the inside of that room shut for another day. There's a whole science living in there we are not going to open tonight.
Before you close that door, though, you drummed it into me last time to always ask where the clean story breaks. So, where does this one break?
The same fence as last time, and I'm glad you reached for it. This whole tidy picture, clean modes, each rocking on its own, never trading, any motion a simple sum of them, is the gentle story. It holds when the swings are small and the couplings are soft, down in that same parabola valley we've leaned on the whole way, where every restoring pull grows in fair proportion to how far the thing has strayed. Keep it gentle, and the modes stay separate and well-mannered, ignoring each other cleanly.
And if I don't keep it gentle, if I really rattle the thing?
Then the fence comes down. Drive the system hard, shove the parts far from home, out where the valley stops being a clean parabola, and the modes stop being independent. They begin doing to each other what the 2 pendulums did to one another. trading energy back and forth among themselves. The clean separation smears. A pattern you pumped up starts leaking into the others. The neat ladder blurs into something muddier. It's a whole story of its own for much further down the road. Tonight's clean choir is the gentle motion choir. Rattle it hard and the voices start bleeding into each other.
So the modes are only truly separate down in the gentle valley, the same boundary as everything else you've taught me.
The same boundary every single time. Near the bottom, it's all clean and simple and adds up neatly. Climb the walls and the simplicity gives way. Keep that fence in your pocket. It's the true edge on the picture, and it's the same edge we've been drawing for 3 nights.
All right, gather it for me then. I walked in with 2 springs and a knot, calling the whole thing a con. Hand it back to me as one thing.
Here's the night in a breath. Couple 2 oscillators, start just one, and the energy won't sit still. It sloshes back and forth between them, a restless trading that lives in the link, not in either part alone. But underneath that restlessness sit the special patterns, the normal modes, where the whole system rocks at a single beat, every part locked in fixed step, no trading at all. For 2, the slow together mode and the quick opposed mode. And any motion you can make is a blend of those modes, drifting against each other. The sloshing was only ever 2 clean rhythms beating.
And then it scales up.
As many pieces as you like, just as many modes. A whole ladder of in-step patterns, from slow and smooth at the bottom to fast and jagged at the top. Stretch the chain into a string and the modes become standing waves. A plucked string is a blend of them, and that blend is the reason music sounds the way it does, and the reason a flute and a violin part ways on the same note. Shrink the chain down to atoms, and those modes carry sound and heat through solid matter itself. One idea, the in-step pattern, the mode, running from 2 twin pendulums all the way up to the trembling of everything solid.
The single note became a choir, just like you promised at the door. So where do you leave me this time? Because you've got that look again, the one that means you're about to swing open another door and leave me squinting through it.
One more door, and then I'll let you go. Everything we've done across the last 2 nights has been one kind of motion. The back and forth, the rock in place, the swing, the string, the trembling atom, all of them going out and coming home, out and home, around a resting spot. We've very nearly mastered it. But look up from it a moment. The other great motion of the world isn't the back and forth at all. It's the round and round.
Round and round, the moon, the planets.
The moon wheeling around the earth swinging around the sun. A whole clockwork of things going, not out and back, but around and around, endlessly. Each one held onto its curving path by a single reaching force. That motion doesn't rock, it circles. And yet, when we take it apart next time, we'll find something waiting inside it that you'll know the instant you see it. The very same landscape of energy we drew 2 nights ago. The same valleys and walls, but bent into a new and stranger shape, doing a job you would never have guessed it could. That's next time. Its name is the orbit.
From the things that rock to the things that circle, and my old energy landscape hiding inside the new motion, waiting for me. I'll be here for that.
Take one image out the door with you then. 2 pendulums and a limp little spring. The smallest coupled thing there is. Trading a single swing back and forth between them, patient and endless. And underneath that restless trading, 2 pure rhythms, hidden, each doing the simplest thing in the world. That same pair of ideas, scaled up, is a plucked string and a singing flute, and sound running through steel, and heat living in a stone. A whole world of complicated motion, and underneath all of it, always, a small choir of simple rhythms adding up.
That's the one I'm keeping, that under every tangled, trading, sloshing crowd, there's just a handful of clean patterns, each rocking away at its own beat, and the mess is only those few pure songs heard at once. So, thanks for tying springs together with us all night. And until next time, when you hear a string sing or a bell ring or a whole room full of something tremble and trade, don't just listen to the noise of it. Listen for the modes underneath. And ask the one question that runs this whole choir. How many simple songs is this really singing at once?